Morning, everybody in Malawi. We send greetings from Zimbabwe. We are very sorry that we have not been able to be with you. But I'm sure that you guys are having a fantastic time there. And we just pray that everything goes smoothly. And we wish that we were with you. And hopefully that we will be able to do this again in the future. So be blessed for your conference. And may God bless every speaker that's there and all of your fellowship in Jesus' name. So this morning I've been asked to give you a little bit more information about soil. Our soil is one of the most fundamental and initial, what we call the first gift that God gave us. As you know, in the Bible, even man was made from soil. Our bodies were made from the mud. So soil was there before we were. And everything about soil is really amazing. People in conventional farming systems ignore the incredible things that soil can do for us, and they just see it as something that holds the plant up. And that everything we do in the soil is either plowing or adding fertilizers or chemicals. All of those things are man-made ideas, and they're not the way that God intended us to use the soil. So what we're going to talk about today is what the soil really looks like, how it was created, and how we should be using it. And first of all, we'd like to look at a little picture which shows the profile of the soil. As I'm sure most of you know, at the top we've got a fertile layer which is normally darker in color. It has the organic matter and where the life lives in the soil. As we go down, we get what is known as the B profile, and that's where the bigger stones and rocks are found. And further down, we've got more solid matter, which is what we call the parent material. I'm sure most of you are aware that soil is something that takes a very long time to make. It's not just created in 5 minutes. It takes thousands of years to make soil. In this picture that I'm showing you here, there's some different images of soil being created. On the left, you can see raindrops falling down on parent material, and that will weather through either water erosion, wind erosion, heat and cold. When things get hot and change in temperature very quickly, they can crack rocks, roots of plants, roots of trees. All of these things help to break stones, rocks, and what we get is smaller and smaller materials being created, which eventually becomes what we know as sand, silt, and clay. Clay is basically made out of a product called quartz or silicon oxide, and sand is materials that are from 0.02 millimeters to 2 millimeters in size. So it's a specific size range of material that is classified as sand. And silt is exactly the same material, except it's 10 times smaller. So from 0.002 millimeters to 0.02 millimeters. That is what is known as silt. Both of these materials are known as inert materials. They're inert means they do not do anything specifically. And they just make up the body of the soil. They make up the skeleton. And then there's a third product that is mixed in with them, and this is what we call clay. Now clay is very different to sand and silt. In fact, I like to refer to it as God's fingerprint in the soil. It's something that proves that God created the soil and it wasn't something that just happened. And clay particles are very specifically shaped. They are six-sided hexagonal shapes, and they are very thin. So they look like tiny plates that are six-sided, and I think they are six-sided because six-sided things fit very well together. I'm sure you will know that bees build their comb in a six-sided shape because of efficiency of space and for storage. So in the soil, these six-sided shapes fit very well together in a very, very small area. I'd like to just show you a quick demonstration using a book. Here we have a book. Now let's assume that this book is a silt particle, and if this silt particle is 0.002 millimeters across. So as a silt particle, it is the smallest particle in that range, and its surface area is the length and the width of this book multiplied together to give a surface area. And we do the same for the other side, and then we add these little edges as well. You add all of that together and we get the whole surface area of this particle. Now that is what a silt particle would look like and how we would calculate its surface area. A clay particle, on the other hand, would be the same as one page in the book. Now if you think about it, the surface area of this page, the length and the width of this page, is the same as the length and width of this book. And it's got another side which also the same. So it's got quite a big surface area, even though it doesn't have the edge here. In relative terms, the surface area of this book and this page are very similar. But in this book there are many, many pages in the same volume, and that's how clay works in the soil. There are many clay leaflets or pieces that make up the same area or volume in the soil. And the other crazy thing about clay is that it is not just inert. It is reactive. It has a negative charge. And inside of the area you could find other pieces of material. So this could be some nutrients of some kind, and in other places you might find other pieces. There's another one here. Oh look, this one is water. So in your soil you will have air, you will have nutrients, you will have water, all stored in amongst these clay particles. And because they are negatively charged, they actually attract positive charged ions. And positive charged ions, for example, are your metals, your aluminium, your iron, your potassium, your calcium, and very importantly hydrogen. And hydrogen is the main component of water. Clay particles also allow the soil to draw water up from deeper in the soil, close up to the root systems, using a process called capillary action. Because of the closeness of the particles together, water can, when it goes in there between the particles, it's actually drawn up. Some of you might have seen this experiment at school, where you use a very thin tube of glass, and you can actually make water go up the tube against gravity. So there are a lot of incredible things that are happening just in the physical makeup of the soil, which don't yet have anything to do with life. And God's fingerprint is definitely on it. It is something that He created, and He intended for us to flourish and to prosper from it. Unfortunately, as farmers, what we do is we tend to destroy that soil in its form that God created. And the worst thing that we can do is to plow it or disturb it in any way. I know you guys in Malawi, you like to make ridges. Ridging of soil is soil disturbance to one of the worst degrees. And I'm praying that you will start to understand that you should not be doing ridging at all if possible, because it is not the way God intended us to use soil. Let's have a look at how soil is made up. If you look at this picture, you'll see we'll start with some sand particles there, the bigger particles. So these big black particles here are some sand particles. Next we add these red particles, which are the same material but they are smaller in size, and we call these silt. So we've got now sand and silt together. And then we add the third component, which is these green ones, which are the clay particles, and now we have all the materials that make up your soil: sand, silt and clay. But there's something else missing. There's a product called humus. Now humus is very important in our soil, and humus acts like a glue. It is created by the decomposition of organic material, so all things, leaves, insects, any living matter that decomposes in the soil and becomes organic matter in the soil eventually breaks down to what we know as humus. And humus becomes a glue that sticks these sand particles and soil particles together, and that creates a ball like this, which is we call an aggregate, a soil aggregate. If you look at this picture, there are still spaces of air between the sand, the silt, the clay and the humus. So water and air will still be inside of this aggregate. But now what happens to make a healthy soil is you have many of these aggregates together, and that's what healthy soil looks like. And in between the aggregates now you see there are spaces, and in those spaces water can collect, and air is also still there, and that's what our soil should look like in a natural, undisturbed state. This soil is very soft, it's easy to work. The roots grow in it very easily. It's full of nutrients, it's full of water, it's full of air, and it is exactly what our plants require for good, healthy growth. In this image you can see a clod in somebody's hand, which is loose soil. This is undisturbed soil that has not been plowed. In the second image you will see a clod that looks very, very hard and compact. In many cases, if I were to give you these two clods in your hand and asked you which one was the plowed soil and which is the unplowed soil, most people say that the soft one is the plowed soil and that the hard one is the unplowed soil. And the reason that people do that is that they believe that plowing makes the soil soft, and if it's hard then it's not yet plowed. But in reality, plowing makes the soft soil become hard. So the answer to the question is, which one is plowed? The hard one is the plowed soil, and the soft one is the undisturbed, unplowed soil, and the way that our soil should be. Now, if we were to put these two clods in water, and I'm hoping maybe that Johan would do this for you, and we'll put some images up here as well to show you what happens when these clods are put in water. Think about it for a second. We've got a soft clod, easily crumbles, it doesn't feel very strong. What happens if I put that in water? We've got another clod which is very hard, it's like a brick. What is going to happen to that clod if I put it in water? Now most of you will be very amazed to see this, but what happens is that the soft clod, the one that is easily crumbles in our fingers, when we put it in water, does not change, does not break at all. Yet the hard one, as soon as it comes into contact with water, it starts to disintegrate and break down into fine particles which just become a layer of soil in the bottom of the water. This shows us that the clod that has been disturbed, the hard one, is very, very susceptible to erosion. And the other one, the soft, healthy soil, when it comes into contact with water, it is not susceptible to erosion. It does not break when it comes into contact with water. So one of the things you need to understand is that once we start to disturb soil and move it, we are making it susceptible to erosion, and when the rains come, the water will pick it up and it will carry it away from us, and our fields will become eroded.